Hey, today I'm down in the situation room at my computer, and I want to talk to you about my project that I had this summer. I spent most of my free time this last summer, in the summer of 2024, building my shed, and it's really just a lawn tractor and storage shed. The intent was to replace two of my old sheds that are about to fall down, one Sears shed that's been leaking for quite a while. And I wanted something much nicer for some additional storage and just to make it more convenient for my lawn tools, my lawn tractor, and then some of my automotive storage. This video is a little bit different than what I normally do. At Stiles Automotive, I do general automotive work, modifications, and tips. I also do some lawn tractor maintenance, motorcycle maintenance, and things like that, but usually automotive type work. And I thought that this video would be helpful for you, and I'll show you my design because I've modified this design, so I'm going to give you something of value other than what the Family Handyman has given us. Now I'm going to break this video down into 3 parts, and part 1 is going to be the slab design and plan. If you're going to do a 4-inch slab and you're on good soil, then you probably don't need to spend a lot of time viewing that. However, I was on a slope and sandy soil, so I did a more robust slab with a footer underneath it. Part 2 is the shed design and plans. In this video, I go into the detailed design. I use the Family Handyman plans, and I show you how I've modified them and what I've done differently so that you can also do something different than what they did in their plans. In part 3, I show you a video log. I'll show you steps along the way. I don't go step by step like I normally do in my videos for my automotive videos, but I pause from day to day and show you an update of what I've done, what the work I've done, and some of the detail to give you benefit over just looking at the plans on the computer. And I hope they're of benefit to you to give you some idea of how to build this yourself. Again, in part 2, I talk about the plans for the shed and where I got them from in the Family Handyman website, and you're viewing the PDF here. I wanted to show you really quick their guidance on the slab. So when you've staked out your location of the shed on your lot, you're ready to pour the concrete slab. We hired a contractor to do this, is what they say. But if you do it yourself, go to familyhandyman.com and search for concrete slab for instructions. So they don't tell you a whole lot about their slab in the plans, but their website is a great resource, so be sure to use that. Prior to doing your layout, you need to first clear the site and then prepare the site and level it, and then set up your batter boards and prep your area that you're going to use. And the perfect area for me would have been where my existing shed is at. It's much leveler than the area where I built my shed. But I wanted to keep my existing shed and then build beside it. And really there was a slope there. Not only was there a slope, but there was at least 7 trees that I had to remove stumps for. 2 large poplar trees, a small maple tree, and then the rest were all oak trees. And I removed the stump on about a 7-inch diameter tree, oak tree, and it stumped me. It was a lot of work. So I had a buddy with an excavator come over and dig out the stumps, which saved me a lot of work. I should have had him do a little bit more work and dig out some of the roots, because those were definitely an issue, but he saved me a lot of work. As I pan around my site here in the video, you can see that I've laid out the batter boards in the corners and still have my strings up where I've laid out my forms, and then put my moisture barrier down, 6 mil thick moisture barrier, and then the rebar is laid out. You can also see the notched out 2x4s in the center to accommodate my rebar. That was to allow me to pour the outside ends, the north end and the south end first, remove those 2x4s, and then I poured the center section last. Okay, let's switch over to the plans, and then I'll show you my bill of materials. So this is my first drawing that I've done doing the layout. So again, 20 by 12 shed, and you can see here that when I laid it out, I did a calculated a dimension for the diagonal so I could prove that I was square. And at some point, I was 21 or 25 and 1 inch and 24 foot 9 inches. So from corner to corner. So I was out of square quite a bit, which I had to pull myself in then, right? I had to pull the forms in to get it back in square. So maybe my layout lines were off just a little bit, or maybe I wasn't right on my layout lines. So handy to have a drawing just to sit. That's simple, but then um, it's nice to have those dimensions handy when you're doing the work. Um, so uh, in elevation view, then originally I was gonna have um, a tapered form, and then have it tapered and with my slope. But then I just decided I really needed that extra footing, and I decided at one point that I was either going to go with a 4 inch or a 6 inch slab. It's a 12 by 20 shed, so a car could fit in here, but I didn't do a door on the end. I did a door on the side, so I'll never put a car in here. But I do want to have some weight on my concrete slab. I want to have some engines in there and some other automotive parts that are going to be stored inside. So I plan on having a little bit of weight on my slab and on my shed. But then I decided with a 4 inch thick slab and then do a footer. And the reason why I did that is because of the slope, and having that big footer at one end, um, and in my forms in this area, I was I was pretty deep. So this area was fine. I was at my easily at 4 inches, but as I took that material out of the footer, then I was able to put that down in this area and bring my base up, and so I didn't have a slab as deep down in this end, and then it worked out good for the forms on this end to be that deep. That's how big of a slope I have. So you can see my forms. I used 2x4s, and those were the pressure treated 2x4s, which I needed a 20-foot 2x4 here on the front wall and a 20-foot on the back wall um, for my walls, which I ended up not doing. Ended up using 2x6s, but this was the original plan. So I purchased four of the 20-foot pressure treated 2x4s, and then here's my 12, or I think these were 14-foot 2x4s I used on the end, and I let them just come out the end. I didn't cut them off because I was going to use those also for my boards, that my wall boards that were going to sit down on the concrete. So, um, and then the 2x4 or the plywood was all could you reuse that for something else, just for scraps and for walking on and things like that. So the plywood ended up being throwaway, but was planning on reusing the 2x4s. So again, once I decided on the 4 inch, just to calculate calculate the slab number of bags. So I ended up with 134 bags, and that's 80-pound quickcrete bags. And of course, I calculated a cost here to see what that was going to cost me. I'll show you that again in the bill of materials in my spreadsheet. And then for the footer, 6 inch wide by 12 inch deep, 6 inch wide, that's about a spade's width wide, and then 12 inches deep. And again, that worked out good down here. And of course, that works out good when you're cutting a 4x8 sheet of plywood. You can cut it into threes and come out with, 16 inches. So 12 inches wide, 6 inches, uh, 6 inches wide and 12 inches deep. And then to calculate that, so I ended up with an additional 50 bags, 80-pound bags. So 210 bags then. So 5 pallets, 210 bags. That's a lot of quickcrete to mix up and pour. That's a back-breaking day and a half. That's what it took me. All Saturday for the two outside sections, and then Sunday morning for the middle section. So pretty intense day doing that. So that's how I calculated how much concrete I needed. So we'll move on to the next sheet here. And before I leave that, let me say that it was my next door neighbor helped me pour the slab. And, you know, that's not any small thing for a friend to come over and help you pour something like that. So that was a big deal to me. I tried not to use him on the rest of the shed, but many times he offered to help out. And yeah, it just helped tremendously to have a second person help me pour that slab. And I really appreciate that. Okay, so we'll move on to the second page. That's just a detail that's showing my cut for my plywood. My plans were to cut the plywood, which made it fairly simple, right? Going back to this drawing. So I had a 4 foot piece that was 16 tall, 8 foot piece, 8 foot piece. Same on the back side, and then an 8 foot piece on the north and south sides, and then a 4 foot piece. So an 8 foot piece, a 4 foot piece on both ends. And then I didn't use it on this end because I used the rocks on this end to complete my form because it was so tall. It was going to be actually a little taller than 16. So that's kind of detailing out the plywood on that drawing. So on this one, I'm laying out my rebar, and I also put some notes. So one reference that I used was this structural design and for foundations for the home inspector, which because it's for the home inspector made it quite a bit simpler. So it helped me figure out, you know, my soil, sandy soil, but clay, and this gave me some of the code information that I needed. That you know, some really for me rules of thumb. But here you can see, you know, the loose for a site, figuring out, you know, the load bearing value of sand versus clay and where I'm at, you know, gravel being heavier load bearing and rock even more, but I was in the sandy clay area. So that's another reason why I wanted to use the footer and then rebar, so to make my cement slab last forever without any cracks. But that's an excellent resource right there. So let me share some of the things I learned. And one of the things I didn't put in as a note, which I should have, is the rebar should be 18 inches on center. So note one, and these wrote all these down as a reminder for myself to make sure that I conform to this. So rebar in the bottom of the footing is better, right? Because the footing's in tension. Note two, the slab rebar should be positioned in the upper third of the slab thickness. Cracks start on the surface, so up towards the surface is better. You don't want it sticking out, of course, and you don't want it too close to the surface, but close to the surface is better. Anchor bolts. Anchor bolts must be located within 1 foot of the end of each bottom plate board. So, like here where I had my door needed bolts, and then the ends of the boards. So wanted to at least conform to the standard, if not improve on it. So note four, position the electrical conduit near the southwest corner, which is this corner, or near the door, and that's what I did. I put it right in this area. Plastic vapor barrier needs to be at least 6 mils or greater, right? 6 mil vapor barrier. So my soil load bearing then load I've designed for 2000 PSF because it's sandy and clay soil. So mostly sandy is what I determined, and I just determined that myself. So in note 7, then position galvanized pipe in the floor to act as an anchor for my or a latch point for my door, which I did not do. I'm planning just to drill a hole in the concrete and screw something in there when I get that far. So that was just an idea though that I was going to do that I wanted to write down. So you can see my layout then of the rebar and my detail. Tried to put a rebar right on the edge of the footer here on the top of the slab, and then the rebars were turned down. I didn't cut them off. So these 20-foot rebar um, get turned down at the end, and so I'm still keeping a little bit of rebar there instead of cutting it off, which I could have just cut it off, but that gives me a little more strength, I believe, and it keeps the rebar from moving. And then these rebar, I cut off 4 feet off the 20 foot, and then these got bent down, and they went down into um, the footer then, and actually got pushed down into the soil slightly, and that helped hold them up while I was trying to put the rebar supports in. And you saw in the video those plastic rebar supports; those are like fairly cheap, 30 cents or 50 cents a piece or something at Home Depot. But those things are worthless. You step on your rebar one time and you break about 6 of them. So one thing I'd recommend you doing is just getting some brick and taking a hammer and breaking up your brick and setting your brick underneath it. That'll support the rebar just fine. And then if you happen to step on it, the brick's not going to break. That's much better than those plastic supports. Let's see, and then I tied it all together. I used the wire tie that you could buy and tied each point together, and that worked out really good. So hopefully the whole system is tied together well. And then of course here's what my brake. I put notched out 2x4s here to so I could pour each end separately, but yet have continuous rebar going through the whole slab to keep it tied together. Um, yeah, so 1/2 inch by 20 foot rebar, and what else? I think that's everything from that I can tell you from this drawing, and then detail drawing, right? So I'm showing that this is my slab. So that's an elevation view. That's my slab, and then I go down into the footer and then down into the soil. And I just pushed them down into the soil, and that helped me support the rebar, and it kept it from moving for me, which was a good idea. It was nice. So the only thing is that this rebar is then out of the concrete, and I don't know what the standard practice of that is, if that rebar is going to rust faster because it's down in the soil. But I did use the moisture barrier here, and I'm going to seal my concrete on the top, and it's not sealed on the side, so moisture could probably come in through the side. But I do have a 2 foot overhang on the roof on the east and west side, and then I have a 1 foot overhang on the north and south side, so it should keep some of the moisture away from the concrete slab. So I don't know if that's standard practice or not, but that's what I did. I kept, them longer, but I cut about 4 feet off of each of those, and they went down in the soil. So there you can see my notch. I was planning in 2x4. So then a detailed drawing for the anchor bolts and how I wanted to lay those out, and so the anchor bolts that are actually set into the concrete, I believe, are much better. I know that's controversial on YouTube. A lot of people say the other anchor bolts are just as strong and stuff, but I don't know how they can be. Once these are set into concrete and they're 12 inches long, or right, I think mine were 10 inches long, but then they have a J hook at the bottom of them, and I believe that's definitely the strongest way to go. 1/2 inch bolts, 10 inches long, and set into the concrete. Of course, I didn't uh, I didn't do this many. This one didn't happen in the center here, and this one didn't happen. So I think on the sides, I think I had ended up with 4 on the back side, and then 4 on the front side, 2 in each of here. But I also went back because uh, my boards, it seemed like my boards needed some extra support. So I went back and drilled some holes. And I put in some 1/2 inch by 5 inch anchor bolts back in this area to give it some additional support because it felt like my board was having a tendency to pull away from the concrete slab here. Maybe because I got my back wall was out of square a little bit or something. So, but planned ahead, and then I marked on my forms where I was going to have those installed, which made it a lot quicker putting those in. So those went in pretty fast. And then the layout of the ramp. This is the ramp, so the slab up here, and figuring out the slope of it. So my door opening, that 8 foot header, so wasn't quite 8 foot, is 8 foot minus 3 inches for my door opening, and I wanted to match that, and that's what matches my break in the slab. So that's my natural break there in the slab, and then I go wider than that. So if I want to approach the door from an angle like this, then I'm wider down here at the end, and so kind of a tapered uh, ramp, and then figuring out what I need for the number of bags. So that took an additional pallet and a half for bags for that. So ended up with figuring out pretty much 8 foot by 8 foot square is what I calculated that as. And then here's a note I used. Discovered I could easily buy some fiberglass fibers and added that into my concrete mix, which I didn't do on the slab, which would have been nice to do on the slab. That fiberglass fibers are, very inexpensive, easy to add in as you're mixing it up. So much easier to mix when I'm up on the slab and pouring it down into the ramp. So that's it. That's the plans, and so let me continue on and show you the bill of materials. Okay, let me close this and go to the bill of materials. And let me unhide this for you. Unhide. So you can see the total cost there of the slab, call it the floor, because originally I didn't know if I was going to do a slab or a wood floor, so I called it the floor. And you can see the number of bags. I separated out so the slab and then the footer there, and then the total number of bags. So Quickcrete cost me $940, cheaper by the pallet, believe, and the rebar that I bought. There's the rebar tie, the tool. There's those rebar chairs, and I paid 29 cents a piece for them. I definitely go with brick and just or a paver and chop it up. So that's what I just said here. That's 4x8 paver bricks, and then the plastic sheathing for my vapor barrier, and then anchor bolts. Those are cheaper buying 25 of them, $1 a piece. I didn't use all 25, of course. And then square washers to put on top of them, give a little bit more of a washer. And then I went back, of course, then the wedge anchors that I was talking about, and corner anchors to tie the stud walls down to the concrete, just to give a little bit of more support. And then the concrete mixer rental from Home Depot, and that was well worth it. It was either that or a concrete truck, right? And I didn't have a way to get a concrete truck into my backyard. And then also renting the bowl float for the day. And then the floor epoxy, that was clearance at Menards. So I got that a little cheaper. Just saw it on clearance in the paint section, so decided to go ahead and do that. And then the concrete forms, you can see there the wood again that I used for the concrete forms. and what those cost me, and then the ramp. So 84 bags, and I went with the 60-pound bags there. I did a little short on the 60-pound bags versus the 80. Um, it's more than the 20 pounds makes a huge difference when you're lifting those and you're tired. So 60 pounds, you're lifting a lot more bags, but it's a lot easier on your back. I'll tell you that. So again, the moisture barrier, vapor barrier, rebar, and then the 4x8 mesh panels I used this time. I used some rebar and laid the mesh panels on top for my ramp. And I kind of figured that I'd probably back the truck up to the ramp and maybe drive up onto the edge of the ramp. So I put a little bit of a footer there, and I want to make sure my rebar was down on the edge to prevent breakage of my concrete. And then again, I rented the mixer again, and that's a 1-day rental this time, so you can see the $124 for that, and then a bowl float again. And then I put concrete sealer on that, so I bought a gallon of sealer for out on that. So I wanted to keep it concrete color, just keep it the regular, make it look like just regular concrete, but seal it. So there I get into the wall framing, and I talk about the rest of this in detail in my part 2 of the video. And so that's all I wanted to talk about. I didn't talk about the concrete work at all and the slab at all in my design part 2. So that concludes this part of the video. If you found it helpful, let me know in the comments, and please subscribe. I look forward to your comments, and be sure to watch the other parts of the video to get more information on my shed build.